We're going to discuss in this segment how to do an automated process for the 5700 made by Fluke. This is a multifunction calibrator and is essentially able to source many parameters such as current, voltage, and resistance. We're of course going to work with the resistance functions of the 5700 because that's what the 6625 system is capable of measuring. So what we're going to do is calibrate the resistance, the resistance generation of the 5700 against the known working standards here in 6625 system. So there's quite a few details for the connectivity of the 5700. One has to be very careful about these connections because they can cause damage if done incorrectly to either the 5700 or the 6625 system, mainly involving the guard systems itself, with both capable of having an active guard, and as well the 5700 can bring the guard down to ground, earth ground, which in both cases this is a dangerous practice. So you want to be sure that you're aware of your parameters. So to do the connection, we usually start with the first thing, which is enable the external guard. So this is making so that the guard system in the 5700 is no longer connected to the active circuit inside. Secondly, you want to make sure that down here, your guard is no longer connected to your ground, which is the factory default way it's usually shipped. So you make sure that this link is broken, and that will isolate the guard from being connected in any way to earth ground. When that is complete, you go into your setup menu and you'll take a look at your instrument configuration, instrument setup, and remote port setup, GPIB, and find out what address you're on. So we're on address 9. So back out of that. Now become relevant for the utility. So over here on the software, we're going to launch the utility. That is down in the plugins menu, and you'll look down and you'll see 5700 cal. So the first thing you do is you set the GPIB address for address 9, which is where the Fluke 5700 will be connected to. So we'll now, using an extra GPIB cable, you'll connect it to a free port on the back of the rack that's found inside, and connect the GPIB cables to the back of the instrument, so that the computer can now communicate with the 5700, because the utility does automate all the processes, including the operation and control of the 5700. Next, we'll want to connect the 5700. So I'm going to pick a couple free scanner channels. Now the connection of the 5700 is a different task, as there are two modes of operation for the 5700. One is the mode for 4-wire measurement, and the other is for the mode for 2-wire measurement. So in order to accomplish this in a fully automated scheme, we need to use 2 scanner channels in the system. And so we're going to use channel 32 to connect the 4-wire measurement. So coming in on the side here, you have your sense, which is essentially your P terminals, and you have your output, which is essentially your C terminals with regards to the system. So this is C1 here. And P1. And then down here, we will have C2 and P2. So this gives us our 4-wire connection on channel 32. Now, what you have to do now is get a 2-wire channel, and to do that you'd have to essentially join 2 wires together, much like you do on a decade box, and place them only on the C's here and here. This is can be done with just using the bare ends of the wire, and you have to kind of twist them together, put them underneath here. What I find is a very useful practice is to use a dual banana jack with the set screws in the back, much like you find in the back of the system with all of our wiring, and I'll just join the 2 wires together right underneath the pins, much like this, and that can just plug straight in and becomes a much easier connection. much easier hookup for the system. And this wiring is very important to maintain. And then lastly, you want to bring your guard up, and your guard will be plugged into the blue post here. And again, make sure that this ground is not connected and that your external guard is on. So now the 5700 is fully connected and configured, we will load our resistors here in the utility window and start with the 1 ohm. This of course corresponds to the working set that's up in the rack up here, and we basically just load in all the values so that we can use them to calibrate the resistances inside the 5700 itself. So 1K, 10K, and as you can see here, they're assigned to the default channels that we generally have them plugged into for the fixed configuration of the system, to keep things reasonably simple. So we have them all loaded here, and you just want to make sure that you set up your channels here for how you've connected it. So the 4-wire measurements I had connected on channel 32, and the 2-wire system I had connected on channel 31. And so what will happen is that this thing will now begin to make measurements in the 4-wire mode all the way up the entire range of the 5700 until you get to 100 meg. And at 100 meg, the 5700 only sources a 2-wire resistance value, in which case then you'll see the system switch to channel 31 to pick up those 2-wire measurements at the very end. And like the other utilities that we have a preview function which just lets you run through 5700 utility really quickly with about 10 samples just to make sure everything's going to work and the connections are good and that you're not going to run into problems. And that takes maybe about half an hour at most. That's actually pretty quick. And then once you're sure that that's going to run, you would hit start on a real utility, which typically takes anywhere from 5 to 8 hours. So this depends on the quality of the 5700 and the quality of your resistors and that sort of thing in your environment, as the software does monitor the quality of the test as you go along to ensure that it's getting the best possible results. But once the system is actually realizing that the results are good in context with respect to the 5700, the software will basically move on to the next test to reconfigure the 5700. So we'll begin launching the test here. Click on start, and it'll ask you for a location again to store the data. And I'll just hit OK to this location here, and then the system will configure 5700. It goes into remote mode. And you can see here it selects channel 1 for the 1 ohm resistor, and 5700 itself is sourcing 1 ohms at this point, and this is being now measured by the bridge to determine that 5700's 1 ohm value is within the specified accuracy. When the test is complete, you can basically review your results. Of course, in a standard manner, we have a report button right here on the utility window. We just click on that, and you can again view current or review a previous file from before. And you bring up, and basically what it does, it has a list of the values as measured and the uncertainties associated with it for the entire range of the Fluke 5700. And of course all the information that shows the traceability of the standards used to make these measurements. And basically you can attach this to your 5700 maintenance file and keep it on hand so you know ohmically what value is actually being produced when the 5700 outputs the ohms value as asked for on the front panel, because it says nominally 1.9 ohms or 10 ohms or 1 ohm or whatever value it is that you've chosen, but the actual value is of course something close to that, but not exactly that. So you want to know that exact value to the tolerances to get the best performance out of the 5700, and this is how you would do that.